Today we are going to solve a non-routine problem. So this is our problem statement that we will discuss about, and the picture that is on the right side is showing its situation that we will meet. So let's read about the problem statement first. A rectangular school garden measures 10 meters long and 8 meters wide. The gardener plans to build a uniform shaded path of width all around the inside of the garden. So the remaining inner rectangle will be used for planting flowers. If the area of the shaded path is 24 square meters, find out the width of the path. So we could see that the width of the path of each side is represented by x. Okay, so for this problem statement, to solve it, I will use graphical method. Why I will use graphical method to solve it? Because it offers a visual and conceptual approach to mathematical problem solving that enhances symbolic reasoning. So through this symbolic reasoning and the graphical method, students could observe the functional behavior of the equation. So in this graph, we could see that how the small changes of x will bring the changes to its corresponding y. So it also assists students to understand abstract relationships more effectively. The graphical method is draw up the graph that represent the quadratic equation that makes students can more understanding this equation, and they can learn the concept of the equation such as roots or shape of the graph. So we are going to use Polier's step in this solution to solve the problem. So for the first step is understanding the problem. So the area of the outer garden dimensions is 10 meters times 8 meters. For the inner area, which is flower planting area, its area is represented by the formula 10 minus 2x multiplied by 8 minus 2x. So where does the 2x come from? The 2x in width is come from the sum of the upside path and downside path. For the 2x in length, which is 10 minus 2x, is come from the sum of the left side path and the right side path. So the total area of the garden will be 18 meters square, while the shaded path area is 24 meters square. So from the question, we could know this information. Then we need to find the value of x, which is the width of the shaded path. So from the problem statement, we could form a formula of quadratic equation, which is the shaded path area is represented by ax. So the formula will be like this. Ax equals to at minus 10 minus 2x times 8 minus 2x. Okay, let's come to the next step, which is devising a plan. So in this plan, we got 6 steps to carry out the solution. So for the first step, we express ax algebraically in functional form. So we will expand the equation in the bracket first, which is 10 minus 2x times x minus 2x. So the answer will be negative 80 plus 20x plus 16x minus 4x squared. Then we simplify it, we simplify and expand it, it will become 36x minus 4x squared equals to 8x. So based on the equation that we have found, we could generate a table of values for x and its corresponding. Then the third step, we can plot the graph of ax against x and draw a horizontal line at ax equals to 24. Then determine the point of intersection to estimate s. And the final step is verifying the graphical result by substituting the result into the original formula. So for the third step is carrying out the plan. So based on the formula that I have found, I have formed a table and the value of x is between and equals to 0.5 and 1.0. So after substitute the value of x into a formula and I will get the shaded area. So from the table, we could get that when x equals to 0.7, ax will equals to 23.24. But when x equals to 0.8, the ax, which is the shaded area, will equals to 26.24. So, if we want to find the shaded area that is equal to 24 meters square, we could get the value between 0.7 meter and 0.8 meter. So next, we plot the graph based on the result that we have found. So this is the part of the graph. The graph is parabola N shape. Since the value of A is negative and the horizontal red line is AX equals to 24, then we could see the intersection point of these two lines is 0.725 and 8.275. So we choose 0.725 to be our value that can be substituted into AX. So we substitute the value into AX. Then the answer will be 36 times 0.725 minus 4 times 0.725 squares. Then we expand it until it becomes 23.9975. After that, we approximating it to 24. So the width of the shaded path is approximately 0.725 meters. Then the shaded area is equal to 24 meters squared. So let's come to the fourth step, looking back. To ensure the accuracy of our answer, we can substitute the result into the formula again to calculate the inner area and the shaded area of the school garden. So we substitute the 0.725 into the inner area formula again. So after expanding it, it will become 56.0025 meters squared. But when we are approximating it, it will become 56 m squared. So same as the shaded area. we put in the answer that we have just found in inner area. So we become 80 minus 56.0025 equals to 23.9975 meter square. Then we approximating it again. So it will become 24 meter square. Then we can ensure that the calculated value, which is 0.2725, is perfectly satisfies the condition that we have met in the problem statement. But why 8.27 cannot be the answer? So let's try to substitute the 8.27 into the formula of length and width. Then after substitute it into both of the formula, we could see that the answer that we found is negative. But although it was mathematically valid, but it is physically impossible because it will make the inner garden negative in size. We can see the length, which is negative 6.55 meters, and the width, which is negative 8.55 meters. It is impossible to occur in the real life. So this solution is rejected. Then after all in all, we could see that the 0.725 is the final and the only answer that can be accepted in this problem statement. That's all. Thank you.